Subscribe now to Astronomy Magazine. Read what the best columnists have to say. Plus receive the latest on what to see in the sky, cosmology, planetary exploration, up-to-the-minute news, star charts, and beautiful astrophotos. Receive 12 issues for just $42.95 and save 39% off the newsstand price. Subscribe today.
Hi, I'm Dave Eicher, editor of Astronomy Magazine. Welcome to Astronomy's How To. Today I'm going to talk about how to collect meteorites. For me, there's nothing like looking in a telescope at the light from a distant galaxy that took millions of years to get to my eye. That's a special and magical feeling the hobby of astronomy gives each of us. But there's another pretty cool thing you can do to capture the magic of space: collect pieces of the distant solar system. Every year, more than 40,000 tons of space debris fall into Earth's atmosphere. Over billions of years, collisions between asteroids knocked pieces of them loose into orbits that, over time, bring some of them to Earth. These cast-off bits and pieces of distant asteroids and comets mostly burn up in the atmosphere, but some of this material hits the ground. Since the first meteorite was recognized in 1492 in Enzisheim, France, sharp-eyed observers have recovered pieces of more than 30,000 space rocks. Meteorites range from ordinary, like Canyon Diablo, a piece of the rock that hit in Arizona and created Meteor Crater, to sensational and pretty, like the Esquel palisite, which is a metal meteorite that also has beautiful inclusions of olivine, to rare, like meteorites from the moon, and even meteorites from Mars. Meteorites fall into three broad classes. The first and most common type are stone meteorites, which are rocky meteorites mostly produced from the outer layers, the soil of asteroids. Some extremely rare stone meteorites are known to originate from the moon and from the planet Mars. Of the tens of thousands of meteorite falls, only 34 are known to be from Mars and 48 from the moon. The most common type of stone meteorites are called chondrites because they have little spherical balls of melted rock called chondrules inside them. These chondrules are mineral inclusions that formed in the earliest days of the solar system when temperatures were extremely high. A slice of the meteorite NWA 869 from Tindorf, Algeria shows them nicely. A rare type of primitive chondrite called a carbonaceous chondrite represents primitive material from the earliest days of the solar system. This little slice of the Allende meteorite, which fell in Mexico in 1969, shows white spots called calcium-aluminum inclusions. These mineral-rich spots of material are older than the Sun and Earth. Two other carbonaceous chondrites are rare, spectacular meteorites among collectors. The Murchison meteorite, which fell in Australia in 1969, contains the first known amino acids discovered in an object from space. These complex molecules are the building blocks of life. The black carbon-like matter that makes up the Tagish Lake meteorite, which fell in British Columbia in 2000, is the most primitive matter known, a time capsule that dates back to the beginning of our solar system. The other major class of stone meteorites is achondrites, those without chondrules. These include interesting types like Millbillillie, which fell in Australia in 1960. Few meteorites can be traced chemically back to a specific parent body, but this one is known to be ancient lava from the surface of the asteroid Vesta, one of the brightest and largest of the minor planets. Rarer yet is this slice of Dar Al Gani 400, a meteorite found in the Libyan desert in 1998. It's a rock that has been broken up and remelted by impacts, and chemical studies show it matches the chemistry of the moon. This moon rock was blasted off the lunar surface and eventually found its way onto the Libyan desert. It's a piece of the largest lunar meteorite, weighing a total of 3 pounds. And the rarest type of meteorite is the Martian stone. In 1962, in Nigeria, a meteorite fell that seemed to have unique properties. Called Zagami, it was classified as an unusual stone until scientists compared inclusions of gas trapped within the rock with the 1976 analysis of Mars rocks conducted by the Viking landers. It was a perfect match. At 40 pounds, Zagami became the largest piece of Mars on Earth. Although it looks like a slice of concrete from a walkway, this piece of Zagami is a highly treasured artifact for meteorite collectors. While stone meteorites come from the outer mantles of asteroids, a rarer type, irons, come from the inner cores of asteroids. The most celebrated of many iron falls is the Canyon Diablo meteorite, which fell about 50,000 years ago and produced the most famous remaining impact crater on Earth, Arizona's Meteor Crater. Iron meteorites contain mostly iron but also nickel and a small amount of other trace elements. While most crystallize in coarse fashion, some called ataxites have a dense crystallization that produces a mirror-like finish when they're sliced and polished. This is the case with Chinga, which was found in Russia in 1913. The rarest and most beautiful of all meteorites fall into the last class, stony irons. These are pieces of iron nickel infused with beautifully crystallized olivine, a common mineral called peridot in the gem trade. These pieces probably originate from the boundary between an asteroid's core and its mantle. The most beautiful of all stony irons are called pallasites, and the best example of this is Esquel, which was found in Argentina before 1951. Sliced and polished, this meteorite is perhaps the most elegant of all. For more on meteorites and how to collect them, get a copy of the August 2006 issue of Astronomy, which was devoted to meteorites. Check out one of the following books or see the following website for a list of reputable dealers. The best place of all for meteorite shopping is the annual Tucson Gem and Mineral Show, held each February and spread around Tucson's many hotels and the downtown convention center. For information on next year's show, see the website. This is Dave Eicher, editor of Astronomy Magazine. Thanks for watching. For more about astronomy, go to astronomy.com. We'll see you next time.